So, I assume you're here for writing clustered applications with Apache Zookeeper and Windows PowerShell. If so, you're in the right place. Who am I? Just real quick. So my name is Tome, not Toma, T-O-M-E. Anyway, Tome, and so I work downtown in New York City at a Fortune 100 company, where I work on like distributed computing, and I live in like the cloud space and helping application teams think about how they redesign their applications in more cloud native and cloud-friendly ways. Within the community, I am an MVP recipient in PowerShell for, I've received the award 8 times. I also honorary scripting guy, wrote the PowerShell Bible or co-author in the PowerShell 2.0 days. But really, the truth is, when I come to these types of things, like this is where I get to share like sort of my hobby stuff, the things that I like to do with it, which is find the things that people are doing out in development practices, finding all these really interesting open source frameworks and things like that, and bring them to the PowerShell community. So some of you, I think, attended my H2O talk, was it yesterday? And so this is kind of in a similar vein as far as bringing something that most people in the Microsoft space may not even have exposure to. So I've given a lot of thought about how we're going to get this started. I could sit down and give you the bullets on here is what Apache Zookeeper is, and here's what it does, and blah, 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 blah. But what I thought would be a better way of doing it is to think about what it would actually take to write a clustered application, and think of it in the context. So this is a thought experiment. As I'm going to go through these, think about how would you actually write a script that would do some of these things. And so start thinking about how complex that would be. So I'm going to start designing this idea of what we're going to be building. First of all, I need to create some sort of clustered environment where people can write data to it, and that data is always available to anybody who can connect to this cluster. Okay, that's a pretty simple ask. You know, you could do that with a database, let's say, right? It doesn't have to be anything specific with an application. But I also need it so that if the node disappears, the data is still there immediately. So then you can start thinking about, object stores and things like that. That might make sense for this type of thing. But that's kind of the idea. If you were to try to write that from scratch in PowerShell, things get a little bit more complicated, right? How do you even get the connectivity between the machines? Is the first step. Am I going to use sockets? Am I using WinRM? Am I using SSH? Like, how am I actually doing that transport? And then what do I worry about security? How do I ensure that only my applications are communicating with itself? So it's a little bit more complicated than just let's maybe use a service out of the box. In addition to the data and wanting access to data that lives there, I also want to be able to add, let's say in this particular case, I'm going to add n number of workers to this cluster. So the application that we're going to be working on today and designing is very simple. It is going to have a master set of infrastructure. It's going to have workers that come up. And I'm going to be able to send tasks to the cluster, and that I'm going to have a scheduler that watches everything and then routes it to the various workers. Okay, and we'll get deeper into it and what that means and how you stitch all that together in a little bit. But that's what the application is actually doing. So from that point of view, I need to be able to add any number of workers. It can be 1,000, it can be 5,000, it can be 2. But they have to be able to come up and immediately start connecting to that. So then when you start thinking of that requirement, okay, so we already talked about how would we even get those connected. So imagine you choose a protocol. We're using sockets, let's say. Or you're using, even if you're using SSH or WinRM. The problem is, it's really about not necessarily the awareness that it's there, it's also about the awareness that it's gone. Sorry, went a little ahead. So awareness that the worker disappears. So if you think of that problem, where when a worker disappears, the scheduler needs to know that that happened so that it can reschedule tasks to a different worker. How would I even write the logic to keep those connections and know when it got disconnected? And then be able to deal with that after. So that's another thing that we would have to write and build. Okay, so I mentioned that in this model, we're going to be sending tasks to this cluster, and we want the workers that are, the n number of workers that are coming up to be able to process that data. As mentioned also, if a worker disappears, another worker should be able to pick up the work. And workers should not process tasks already processed by another worker, so we need to be sure that we're only processing one thing at a time, so like an MQ might be more difficult to write here or something like that. But we want to make sure that once the job is completed, that nothing else is going to consume it again. Also, I want to be able to build the custom logic. So I've got this cluster. I've got these workers that are spinning up, but I also need to be able to write some logic that will intelligently route and decide which workers to use. So a good example of this is, imagine that I've got workers coming up that some of them have GPUs. Okay, so I may want to tell the master cluster, okay, I'm a worker, but I have GPUs, and then as a task submitter, I'd like to say, I'd like to submit this task for a server that has GPUs, right? So now, in order to do that, I need some custom logic. I need a scheduler that's looking at these things, evaluating what the state of the plant is, and then making a decision about which workers are the right ones to use, okay? So this is a clustered application. The other thing is that scheduler logic, the thing that's making those decisions, if that server that is managing that scheduler logic disappears, it needs to also come back up, right? We're talking about a true clustered, highly available application at this point. So in addition to the workers disappearing and being able to bring up new ones, the thing that's making all of the decisions about what to use, if that disappears, it needs to be as if it didn't happen and something else just takes over. Okay, does any of this sound difficult writing it natively in PowerShell? It's nearly impossible. Like it's a task you can do, but there's a lot to think about. You know, you have to think about how things get disconnected, timeouts, all of that stuff. This last bullet here is just the interface that eventually we're going to create. So today, by the end of this, I'm going to write, send a task with a command. We're going to say what command we want to run, and then the worker's going to execute that and dump the output to a file. Okay. So how do we do this? And the answer is, let's look at Apache Zookeeper because it does everything for us. Pretty much everything that we're going to be talking about gives you sort of so a Zookeeper gives you these sort of principal fundamental building blocks to build a clustered application. What you do with it is really up to you. And so we're going to take the requirements here that is one type of clustered application. There are many types that we can have. There's many other ways that we can design this thing. And we're going to start stitching it together and apply and look at what it looks like. In order to do that, we have two things that we're going to grab from the open source community. One is Zookeeper itself. So it's on zookeeper.apache.org, which you can download. The other one is a module that I wrote that's on GitHub called PSH Zookeeper. And this, just so you guys know, this particular GitHub, the markdown here, it actually has this reference application. So there's a couple of the examples that aren't there. I'll try to get them up before as the conference ends. But in the meantime, you can take this today and you'll be able to run this. You'll be able to launch Zookeeper and run it. So what I want to show you is how Zookeeper actually, like what exactly is it? How do we get it started? So this is my Zookeeper directory. And what you find is there's a configuration folder. You only have to change one thing after you download Zookeeper. It's in those instructions. You unzip it, look in this configuration directory. You won't see zooconfig in there. If you look, zooconfig is exactly the same as zoosampleconfig, so that's all I did was copy it. This is your basic Zookeeper configuration, so it has some information. This talk will not go into the configuration of Zookeeper. That's out of scope for this. We're talking about how to leverage it after it's up and running. But just know that it's a clustered type application. There's lots of configurations. It's an infrastructure application, so you'll have to think through and really understand it if you want to deploy this in production. In the meantime, the only thing I do care about right now is I've got a data directory called temp Zookeeper, which I'm just going to make sure is empty before we continue. That's a good question, actually. I purposefully didn't look while I was preparing everything because I was like, if I have to update anything at this point, I'm sure all my demos are going to fail. So I'm not even going to do a PS version table at this point in time. But all right, I'll do it. 5.1. All right. So anyway, let's start Zookeeper. So the next thing after you create that's configuration there. There are a bin folder, and within the bin folder is a ZK server CMD. So this works perfectly on Windows as well as Linux. And you can see that it's basically up and running, and it's binding to this port down here, 2181. Okay, so it's up and running at this point. What I want to do next is there's one additional tool that I want to make you aware of. It's called the Zookeeper CLI. So if you go back into that folder, this ZK CLI CMD. So far I haven't told you actually what Zookeeper actually is, and in a second you're about to find out, because if I type help at this little shell here, you see a lot of commands that look pretty familiar. ls stat, I mean, these are file system commands, right? That's all it is. I mean, they're a little bit weird, right? Some of them seem to be doing some strange things, but there is an ls command. And so if I look there, I see, obviously you have to do the paths, full paths. But in the end, this is just a file system. And now, keep in mind, I'm running one Zookeeper at this point. You would usually run it in a cluster, so you run 3 of them, or I think with some configuration of them. But it'll keep a quorum, so this way, if one of them goes down, this file system is still available. So that meets one of those requirements that we were talking about at the beginning, right? So far, we've now met the requirement of this. This one obviously could be dealt with like an object store or something like that. It's not that you need Zookeeper for this. And sometimes there is a question of whether or not you should be storing certain data within here or not. But the point is that I just want to show that it is a file system and that there's data accessible in a clustered fashion at this point. OK, the next thing we're going to do is actually leverage Zookeeper, and I'm going to, in PowerShell, using that PSH Zookeeper module, I'm going to show you how we write a quick application that will just simply write some directory here. That's all I'm going to do, because it will explain kind of how you build the applications themselves. So let's create a new window, and let me just get into my examples. So the first one I'm going to show you is, like I said, it's this O1 persistent, and let me just open up a little thing down here. OK, so the stuff at the top is my Chrome. Don't worry about my parameters at this point. The computer name here is simply, it can be a list of computers, so the list of master Zookeepers that you spin up. So if you spin up 3 Zookeepers, you can put all 3 host ports in there, and it will choose which one to connect to. It deals with all of that for you. The other thing that I have is I use this very frequently. It's basically a way of getting the current directory so that depending on how I'm executing, if I'm in a shell versus if I run from PowerShell, it'll always have the current directory in a standard format that I like. So this way, if it's running from PowerShell, it'll do it from the directory at which the PowerShell script exists. And then in this case, I know that my module is a directory below, so I'm just doing it this way. This is not necessary. This is not for any point of this other than just making the examples work really fast and prototyping. So pay no mind to that. There's definitely better ways we can do all of this stuff. This is an entire Zookeeper application, though, what's written up here. OK, so if right now there is only this main entry point, which is connect Zookeeper. Connect Zookeeper comes with the PSH Zookeeper module. You specify your computer name or the list of Zookeepers you want to connect to, and then you create a script block with an action. Those script blocks have the access to a very special variable. So here I'm calling new persistent. And if you notice, the new persistent function I'm creating is a global. And you're going to have to do that. So anything that you want to keep as far as state within the application and make accessible either to these script blocks or to, eventually, we're going to get into events. So when we see a change on something, we'll want an event to run. Anything that you want to manipulate as far as state goes, you'll want to keep that in global scope. OK, but once you have that, if you look, the functionality here is simply take this global object that gets imported the second you create Zookeeper, use the module connect Zookeeper, and pipe it into new ZK persistent node, and we're going to create a directory called /blah. We can then catch whatever exceptions we want and move on. The other thing you'll note here is that I'm writing the word string completed to the function. That's because it's a specific mode of running this. Connect Zookeeper by default will run in a loop unless you actually eventually send a signal of completed at this point. We can talk about whether that's the right way or not, but when it gets the signal completed, it will actually no longer process anything. It'll die. So let's actually run this. So that's my, oops. OK, so I'm going to run this, and you'll see that it, oh, hold on a second. I think I might have a still state. Actually, it looks like it worked. Yeah. OK, so there's blah. And if I look here, it's empty. There is a command called get. And why I'm showing you this now is you'll notice that there's the number 0 up here. The module that we create actually defaults to a 0 value for anything that you create that's a node like this. So if you don't specify some data. So the question then is, well, how do I specify data? And for that one, it looks like this. So I come back down. I've got my connect Zookeeper function here. And my connect Zookeeper function is going to call this new persistent. New persistent is going to do the same thing like before. It's taking ZK client, piping it to a persistent node. And then here you see I'm using the data switch. So in this case, I'm actually going to send in an expression that gets evaluated. So it's basically going to take the current directory, select name and length, and convert it to JSON and put it in there. The next line here is the one we're going to do next, which is showing just how you update that. But let me actually run this so you can see. You can see what it looks like in Zookeeper. So that ran, and now we should see in the data folder here. So get data. And now you see up at the top here, there's an actual JSON object embedded in that file or in that path. Okay, so it should be obvious that now I can get this data, right? So that's pretty simple. The other thing I can do is I can do that update. So let me just run that update so you can see that. And then we'll get into the real stuff. Actually, I think there's one more, and then we'll get into the real stuff. Okay, so here is, we're going to run this again. And it looks like it updated something. I obviously have a message that popped out. And so if I do a get again on data, I should see it updated with the word knock knock, which it's right there. Okay? Pretty simple. File system, nothing magic here. We've all interacted with file systems before, hopefully. All right, so the next thing that we're going to do is we're going to look at one more function for persistence. So it's called sequential. So this is the idea. So remember, we're going to have there's a bunch of tasks that are going to come in. Something that might be important to me on those tasks is knowing which one came in first, right? So Zookeeper has an ability to create a full file or something with a sequential number. And that's actually all I'm going to be illustrating here. So it's the exact same code as before. We do our connect Zookeeper. We call out our new sequential. That's the function that we're going to call. In this case, we're just calling this new ZK sequential node. You'll notice that it's called blah task dash, and there's nothing after it. And then input text here, it's not expanded. That's just the text get processed. This is simulating the idea of I'm going to send a task. It's going to say what to run, and then later on, we're going to totally inject that and run that and make complete security holes everywhere. But anyway, in the meantime, we're just going to run this so that you can see exactly how these manifest in Zookeeper. So I'm going to run this, and you see that it created blah task 000, and if I run it like a number of times, you'll see it keeps creating new ones. So I'm up to 3 of them. And then if I come over here, and we look, we should see ls blah, and then we see all the tasks in there. And if I do a get on one of those, and we'll do it on one, you can see up at the top that the text get process is in there. Okay, just another handy kind of thing that you might need to be able to access. All right, that was the boring stuff. Now we get to the fun stuff. The next one is the one that kind of changes everything. And once you see this and understand what's happening, it'll start to, hopefully it'll start to resonate with why exactly we're even looking at this. And what it's called is ephemeral. So in addition to creating a static node, like a permanent node, I can create what's called an ephemeral node. Ephemeral means that it's fleeting in nature, right? It's going to disappear. So remember we were talking about the fact that, how would a worker come up, and how would it tell itself that it's there, and then if it disappears, how could we find out if it's gone? And that's exactly what this does. So what's going to happen is we're going to create this /ephemeral file, and then when it's connected, while I'm in the session, that file will always exist, okay? When I disappear, when that connection breaks or whatever, the file itself actually disappears. And so in a second after this, we're going to talk about the things you can do. You can set all sorts of events to watch that stuff so that you can do actions and respond to various things that are happening. But let me actually just show you what the ephemeral looks like. So 03 ephemeral. So we run that, and it's running right now, so therefore it should still be there. And if I look in the file system, I see ephemeral. And I don't think there's any data in there. Default name, I think, is what it set to, and it's still there. Now, if I come back here and I exit it, I will say I do have to restart. I have a whole bunch of jobs running. I could just restart the jobs, but it's easier to do that. So I reset the session, and now if we watch on the top thing, you see that it says close socket connection for client, and it's, yeah?
So you were still in the connect because you hadn't output completed?
Correct. It stays in the loop. That's the way a Zookeeper application would run. It would run perpetually. It's all event-driven. It's all in response to callbacks and things like that. So that's how an application gets built in Zookeeper. It's all async. OK, so here you can see that it said first it timed out, it disappeared, and then you can see the process session terminated. And so now, no ephemeral. OK, that's pretty magic, actually, especially when you see the next thing that I'm about to show you. This is how you actually do the events. So in this particular example, we're going to use Ephemeral in a very specific way. So remember I said that the master scheduler, we're going to write scheduler logic at some point that's going to be watching Zookeeper and manipulating it in ways that everything will orchestrate and everything's going to run. Okay, before we can do that, we know that only one thing can really watch Zookeeper that way and do all of that manipulation, because if we had two things doing it, there would be a lot of clobbering, there would be a lot of, who knows who would be in charge. So the pattern that's used within Zookeeper is what's called leader election. And it's very simple. I'm going to write an ephemeral node with a very common name that everyone's going to try to get. So the second your application comes up, you're going to try to write to / ephemeral in this case. If you happen to get that, you're in charge, right? You're the leader. If you don't get that, what you have to do is because you want that thing to be there on standby so that if the master disappears, it takes its place. What you want to do is try to access it, find out that you didn't get the access, and then set an event on that to basically watch, and then create a script block in response to that that is going to basically go back and try again. So the second it sees that it disappears, it'll try it again. If it succeeded, it works. If it fails, it will just do the whole process again and have the watcher. So this is what it looks like. Actually, I have the wrong one up here. Leader election. Good. So it's a little bit more complex when you add the handling. But okay, you can see right here that what we're doing is our connect Zookeeper. We're running new master lock, and we're going to go up here to new master lock. The first two lines means it succeeded, right? So if it gets to this point, it's done. All right, it created the new node, it owns it, it doesn't need to watch anything. We didn't need to watch anything because it honestly doesn't matter what happens at that point. I'm the leader. If I disappear, I'm dead anyway. So the next thing that I have commented out here is start master, because when we see the full application, this is where that logic would go. So you'd start building and doing your scheduler logic in there. Maybe I should call this start scheduler. Anyway, here's the point at which if you don't get elected, you create and I completely forgot to mention that my Zookeeper module actually leverages a .NET open source project called, exactly what it's here, Zookeeper Net. So there's a DLL that's bundled that you'll get. I've kind of bundled it with the Git project for now, even though that's not ideal either, but just to get people working and using it quickly, I think it works fine. Okay, so I create this watcher object, and then I have to register. If you look, the register object event is just the normal PowerShell register object stuff. So I'm basically saying I've got this master watcher, and I'm looking for the action changed. And then what I do is I basically grab the message out of there. So there's some source args that I grab. I get the state, type, the path, and I start using this stuff later to figure out what was actually being called and stuff. And here I say, OK, if the message type was node deleted, and the message path is master, let's just double check and be safe. Run new master lock again, so recursive. So it's an event, and when it triggers, it's going to call that function that's we're in right now again. And so the process starts over. It will try to get the lock. If it doesn't get the lock, it will set the event again. Okay? And then finally, if there's something unexpected, it throws it. Now, one other thing to point out, so up here in the register object event, I haven't actually set this to anything yet. I set it down here. So the way Zookeeper works is every time you either look at a file or try to open it or read it or anything, you can additionally add the event after that. And that's kind of the pattern at which Zookeeper works. And the reason for that is to avoid race conditions. So you basically can set one trigger. When the trigger happens, you have to read everything that's there, because there could be other things being manipulated. At some point, at the point at which you read it, you're going to read it again and set the event again. So once you get whatever the current list is, your event is now alive again. And so therefore, if it happens again, you'll start to get it again. And so that's the pattern you repeat over and over with Zookeeper, is access, try to get something, set the events as you're doing it, and then stitch together the logic that way. You can kind of almost think of this as like, kind of serverless in that it's, in its design, right? But anyway, so let's actually run this. So right now, it's going to try to grab this master. Oops, that's the wrong one. Leader election. OK, so this one, I think I have a name parameter. I'll just call this master1. OK, so that loaded up, and it's now the master. And let me just make one to the right here. Examples, and that was 04. And we'll give this a name, and we'll call this master2. OK, so you can see that it was not elected master, right? It's sitting right here. And then if I happen to kill this one and restart the session. What you'll see is it takes a couple seconds for the connection to get noticed, right? Because it has a timeout. You can configure that, by the way. That is something that can be configured. And you can see that the master watcher triggered, the new node was created, and now it is in control. It is now the scheduler. And that was all real time. That was without, this thing is immediately taken over. It's immediately able to set all of its watchers and everything else. Cool? Now you're starting to see the power? All right. So now we're going to stitch together the whole application. So I'm going to show you what an application looks like, and I'll talk about the structure and how you design these things, because it's really just a matter at this point, now that we have all these principles, it's a matter of understanding, well, if I design this folder structure here, and these things are watching this, and these things are watching this, and these are the things that they're going to do when they're watching it, and respond in response to change, then that's the complete application. OK, so what does that look like? I'll create, let me close this. Just exit this one. OK. OK, so I have my master logic. So this is identical to what we just looked at, with the exception that I've added the scheduler logic to it. And that's, I kind of want to just walk you through this. So I've got connect Zookeeper down here. I do my new master lock, which is what we just looked at. That's right here. So new master lock goes, and then it calls start master if it wins. So let me go to start master. OK, so this is the function start master. And actually, this status one isn't even needed. I'll just leave it, but it's not needed. What I do is I'm going to first create my persistent nodes. And I'm creating a folder called workers. I'm creating a folder called assign, and I'm creating a folder called tasks. Normally, I use a whiteboard at this point, but I think I'll just explain it. Workers is the folder that I want any worker that comes up to self-register in an ephemeral nature. So it's going to connect and say, I'm here. I live. I exist. Assign, I'm going to have the workers come up, and every time they come up, they're going to create their own worker folder in assign, but it's going to be a permanent one. Okay? The reason for that is that's where I'm going to move things from tasks. So tasks is our entry point. That's going to be our sequential one. Things are going to come into tasks. My scheduler is going to notice that something came into tasks. It's going to have an event there that's going to look and say, oh, I have a task. Well, let me look. Do I have any workers? OK, here's the workers I have. I will I will send this task at a random to one of those workers. And the way it does that is it just copies it from tasks to assign to the worker that it needs. The workers themselves are going to have events watching its assign folder. The second it sees that, it's going to actually do the processing. And then the final thing that we also have to think about is the failure scenario. What happens if a worker disappeared and there was a task assigned to it? So that's why this has to be a permanent, the stuff in assign has to be a permanent node. Because what happens is the workers node, it's ephemeral. It disappears. I see that it disappeared. I then look and assign for that computer, and I see what it was assigned to it. I then can reset that by moving it back into tasks, at which point the scheduler logic all takes effect, and it resets, and it will reapply the whole thing. So you don't have to code anything special. It just deals with it for you. So I'm just going to briefly look at the stuff afterwards, because there's two watchers. So as I mentioned, we have the new workers watcher, and we have the new tasks watch. So the workers watch looks like this. So basically, this is the event, remember. So remember, the event gets set down at the bottom when we access it. So we're actually reading all the workers in here. And what I'm doing is, remember I mentioned that if you use a global variable here, I can actually maintain state in memory. So I can actually keep track of the workers I know of in memory. So here you can see I set global workers equals to the workers that I'm getting from these folders. And then what I do is, because I really care if, it's not so much that I care if new things are added, I care if something was removed. So that's why I need to maintain that state to see what it was before. I compare it, I say, OK, this changed, I've lost a worker. Well, if that's the case, then I need to look at everything. So you can see it right here. This is where it finds a new worker and it just basically adds it to the list. And then down here, it's going to basically, it says that it was removed from the list of available workers, at which point I have a function that I can pass assign and $, the worker name, and just it automatically resets those tasks. And if you go to reset tasks, you'll see that it just basically copies it from that folder into the tasks folder. That's all it does. The other watcher, as I mentioned, was, I have to go down to the bottom because I forget the name. It is moves. Apologies. You're absolutely right. Copying it would definitely be a bad idea. You have state and conflicts and all sorts of nonsense, which is kind of funny because that's actually what troubleshooting these types of applications becomes. It's a lot of stuff like that. Yeah. OK. So the other one I just want to make sure you see. So start. That's not the,
So the actions have to be at a public?
I'm sorry, define. So,
If one worker's working on it and halfway through it, it dies, somebody else is going to do it.
yes. Correct. I mean, this is the design of, so at the very beginning, we gave a bunch of requirements, and it's a very simplified application. There's way more things to think about when you design these clustered applications, and it's all that stuff. And that's what you have to do. You have to like traverse the path of logic around clustering and what the communication is actually happening. Zookeeper is great as far as a framework goes, but you still have to build the logic, and you still have to, you know, figure out if it applies in the right way to the application you're designing. Okay, and then here's the task swatch. So this was the other one. So we're basically just, we get the children for tasks, and then we set the event task watcher, and then down here you can see for each task that we find, we basically start the task. I have another function, starting task remember. We copy or we move from tasks into one of the workers, and let me show you that because that's the actual scheduler. So you can, oh, hold on, I think it's start. Okay, so this is the actual scheduler. So you can, the really interesting thing to think about here is that right now, all I'm doing for a scheduler is get random. So I have the list of workers, and I say get random, and just run it on one of those. I'm moving it into that ZK node. But here you could add all sorts of logic, right? Because the workers themselves can self-represent. So when they do that ephemeral registration, they can basically say, look, I've got GPUs, I've got an FPGA, I've got this, I've got that. And then at that point, your scheduler here can look at it and say, okay, this task is asking for a GPU. Do I have one? And then it can look and schedule it the appropriate way. The really interesting thing is that, so this is actually, I haven't mentioned where Zookeeper is used. Zookeeper is the foundation of what Mesos was doing with containers. So that's what they built it on. Kubernetes wound up building on etcd. You may hear that one. Another one that you hear sometimes is Console. These are all kinds of, clustering type platforms that you can build on top of. They all kind of work in a very similar way. Zookeeper is better at sort of, in like one data center, not across a WAN. etcd works better across a WAN, but when you're thinking about clustered applications like this, sometimes you really don't necessarily want to be across a WAN. But it also has some other characteristics in that it's HTTP only, whereas this uses sockets. So there's trade-offs with everything. But since we're here talking about Zookeeper, I'm just going to keep going, and we're going to actually run this thing. Okay. So the first one here, I'm going to run the master. Oh, I have to show you the worker logic. Apologies. Okay, so the worker, remember the master has already come up and set up those folders. I do my connect Zookeeper, which calls start worker. Start worker is going to create a persistent node. So in assign, remember it's creating that static one that the master scheduler will put tasks into. It creates the ephemeral one called workers, which we saw the logic before when we're evaluating whether workers have changed or not. And then we basically just have to watch that assign folder. So you can see that it goes to new assign watch, which looks like this. So in this one, all I'm doing is I get everything that's assigned to me. And for each one that's assigned to me, I run StartTask. And this is a different StartTask. Probably should have had a different name, but StartTask in this context, I actually want it to execute. So what I'm passing into StartTask as an object, no, it's a path, sorry, apologies. I grab the task out of Zookeeper. I convert it from JSON into so I basically deserialize. I now have it in memory, and it's this data object, which has a CMD property. So when we send task later, we're going to create something that has a CMD equals something. Whatever that CMD equals is what's going to get executed. So in this case, this is really bad. Please, again, prototyping just to prove. But anyway, here you can see I'm basically invoking this whole thing and then spitting the output into a folder. The folder is going to be we're going to create a worker directory with the task ID. So this way you can see the output of what's actually being run. Okay? So now that we have this, the final bit is that send the task, which I kind of showed you before, so I'm not going to go into that one. But I want to show you it actually working. So because we will only use one master right now, there's no reason to use any more. So I will create the master. OK, so there's the master running. And I will create some workers. So there's a worker. Oh, I should have given it a different name. Oh, that's all right. The default was worker 1, so that's good. And I'll create one more. And this one we'll give a name. And just, again, if you notice, I'm just running the, oh, shoot, that was the wrong name. That name exists. So it was trying to basically apply the same name to an ephemeral node that already existed. So that gives some serious errors. But here I'll just say name. We'll call it worker2. And we'll see that it runs. So you can see on the left, the master detected the change. It knows that worker exists. So now I just have to send the task. I'm just going to pull it from the GitHub because that has the syntax perfect. Here it is. So as I mentioned, we're creating an object. It's going to have the CMD, and in this case, we're just going to run get process. So I'm going to send a bunch of these. And you know what? I'll just do it to the right of this. This way it's all on one screen. You can see all the actions happening. Paste. OK, there it goes. So new object, PS project, get process, pipe into the SendTask script. And there it goes, it runs. And you can see that basically what's happened is, top right, the task was submitted. It got created. Down in the bottom over, where the heck, let me look on the thing. In the bottom right, there you can see the task actually gets detected and then processed. And so that worked. And then the cool thing is that I can send a whole bunch of these. Right? It really doesn't matter. And if you look, they're getting picked up by various workers because we did get random. So you can see some are getting processed there, some are getting processed there. And then, as mentioned, the output of all of this should be getting captured. And that will be here in the directory that we're working in. You can see the two worker names. And within there, you'll see the tasks that ran. And now I can look at the output. And there we go. Powerful? Cool stuff?
So what's like a practical application for?
Yeah, well, I mean, the container one is obviously a pretty good practical one. The thing that gets more interesting is when you think about it, maybe not in the context of writing like an executor type thing, but where people use Zookeeper a lot is in, so one of the big problems with cloud native and moving to clouds is that you don't know where things are. Who knows where things are, how they're stitched together, all of that stuff. So some people use Zookeeper for discovery alone. They'll have services self-register. And actually, that's the last point I was hoping to make, so I'm glad you brought that up. You can basically think of it, you could do like red-blue patterns, right? If you have the clients connecting directly to Zookeeper themselves, you could have business logic in there. So I could say, my client, which connects to the Zookeeper and says, OK, I need a place to go, and I've got logic that instead of putting the scheduler in a master, I put it in the client itself. And it looks and sees what's available, and then it makes some decisions. It says, oh, you're in that department, and you've got the task you're asking for, whatever you're asking for, seems to be affecting customers of this size or something like that. We need you to use this backend service. And so you can build whole together an architecture and topology of decision making and branching off of and routing based off of logic. And so you can do that, and it's really up to you how you use that. You can do red-blue patterns. Another thing that some people do is they stitch it together so they'll connect like an Nginx or an HA proxy to a Zookeeper. And then so this way you can do HTTP routing. And so the client doesn't actually have to connect to Zookeeper, it connects to the proxy. The proxy then routes it to the appropriate backend service.
So I'm using Nginx now, so that's why I'm trying to understand what would be a good reason for a switch.
Yeah. So a switch from Nginx, are you using it with Zookeeper? Or are you using it?
Using Zookeeper, what does Zookeeper add versus something like Kubernetes or just trying to?
Yeah, so Kubernetes is a full platform for container execution. This is more of just it's really what you want to use it for. So the idea is that you have these principles, you have the ability to kind of stitch these things together. So it's really a question of, where does that make sense or not? And the thing, like I said, the one place where I see it seeing huge value is as those containers are coming up, having them self-register to various services. This way, if my service starts in Kubernetes, or it starts on a Linux host or a Windows host or an Azure host or wherever, it just reports its state back to Zookeeper. It really doesn't matter what cloud it's running on as long as that thing gives my clients the information to be able to connect to them on the back end. Make sense? I mean, I don't know how you're using Nginx, but the idea would be that you would eventually, Nginx has to be aware of where everything is also. Like, it doesn't just know about those things, so that awareness has to come from somewhere, and that's usually something like a Zookeeper or an etcd or a console. Yeah. Any other questions? Actually, they gave me a sticker. Since you asked the question, you can have this one. I guess they had a couple left. All right, I'll throw it down here for now. Oh, no, I won't do that to you. So any other questions or practical applications, things that you think might be usable from this type of tech?
What have you used it for?
We built our container orchestration system on it back in the day. We also use it for service discovery. So some teams in our company use it heavily for service discovery. You do get into problems, though, because, like I said, you do have to question whether or not you should be storing all of your state in this, because while it can act like an object store, it really has a bit larger purpose. It just depends on your needs. Usually, because Zookeeper is the center of everything, and everything, like, that's the thing you invest in. You invest in making sure that it's rock hard, it's solid, that it can tolerate massive failure, that kind of thing. And then and part of that is making sure that you're controlling the client connections to it and how they're connecting and how they're using it. So like anything else, it's all conditional. If people are abusing it in one way, it may not scale. But if people are using it in another way, it can scale to like hundreds of thousands of connections, right? Like it's all variable. And it's going to depend on your hardware, what you have under it, and all of that stuff.
So are you actually using this with PowerShell in practice now?
No, this is academic. I do this for fun. That's really the point of it. Like I said at the beginning, I like to take this tech, this stuff that's out there. I find implementing and prototyping in PowerShell is a great way for me to reinforce my understanding of a tech. And it has the side benefit that nobody else has seen it, so therefore you guys can actually enjoy this, and if you find practical application, you can use it.
Don't some people use this as a distributed configuration?
Yes, yeah, you can use it as distributed configuration too, but then there's a question of whether or not you should be, because actually that's the one place where it's probably least suited, because it doesn't have like version history or change management and those kinds of things. Config management, from my experience, that's where some of the value is in being able to do the rollbacks and look at the change over time, where something like a Git or works a little bit better in that space. Now, you could say that your config store exists and then serialize that into Zookeeper, to which point the config can come up, like if a server comes up, or it can grab the config out of wherever and use it. So.
And my understanding was it was for fast twitch resynchronization.
Yeah, I could have fast twitch resynchronization. I could definitely imagine that. Yeah.
So my issue now is I'm trying to compete with like Spring, right? So I have my Java developers, they're doing a big enterprise thing that we manage.
Yeah.
And I have PowerShell applications running in containers that don't have that like auto registration, that auto help.
Yeah.
So, like, I'm building a lot of that myself. So I'm kind of looking at what can I use to kind of.
This is one of the ones that you could use for that. Yeah. Yeah, and I mean, we've even stitched together a lot of our Java apps are actually reporting in for the routing reasons, like actually figuring out backend business logic, all of that stuff. We're doing it with Spring and running some Jetty instances and things like that.
Yeah, or tangential. Is that Linux, or are we using Disclosure?
Oh, ConMu. So I use ConMu exclusively, and I use Vim. I've always. Actually, I haven't always. I used to use PowerShell ISE, to be honest. But once I got back into the Linux side, Vim is just so much faster for me. And I know there's key bindings now in VS Code. It's just old hat. Cool. All right. Well, thank you, guys.